Hello, George Hepworth, Grover Park Consulting. Welcome back to this series on migrating the Northwind template from Access to PowerApps. Now that we've seen both the original Access version of Northwind and the PowerApps version in action, it's time to look under the hood. This episode is all about setting up the development environment, specifically migrating our data from Access to SQL Server, connecting PowerApps to that database, and making sure the relational structure stays intact. Let's dive in. To get started, I used SQL Server Migration Assistant, SSMA for short. This tool automates most of the work of converting Access tables to SQL Server. You just point it to the Access file, select the tables you want, and it handles both schema and data migration. In the Northwind Developers Edition, most of the core entity tables migrated smoothly. Products, orders, order details, purchase orders, companies, and so on. But not everything maps perfectly. Access has some data types that don't exist in SQL Server. The most important here is the multi-value field type. Here's the employees table successfully migrated from the Access database to the SQL Server. I've expanded the columns so you can see all of the fields in the table with their data types. I won't go into this in detail. That's not the point of this series of videos. Very quickly, the data types that you see here are similar in most cases to the data types in the original Access table. Short text becomes an nvarchar with the length specified 20 or 30 or 255 and so on. Notes is a long text field which becomes an nvarchar max. Here are my three fields that are intended eventually to handle my images. As I mentioned earlier, PowerApps seems to work more smoothly with the image data type. The var binary max data type is considered more appropriate in current usage, and I added a field for the name of the image if I decide to store the images externally to the database. That's another option. Supervisor ID is a self-referential key, foreign key, to the employee ID. In other words, each employee can have one supervisor. So the employee ID for the supervisor will be stored as a foreign key in supervisor ID. Windows username is used in the Access side for the multi-user login. We'll implement that later here. These four fields are the audit fields. In Access, they are populated by data macros. Data macros are the equivalent of triggers in SQL Server. In the SQL Server database, we use triggers to populate our audit field. I need to scroll down a little bit to find the trigger. It's here. It's called Audit Employees. If we look at what it says, we can modify the trigger. Triggers depend on two special tables created and managed by SQL Server for this purpose. Those two tables are called inserted and deleted. When a record is either inserted into a table or updated, a copy of that record is placed in the inserted table. When a record is deleted, a copy of that record is placed in the deleted table. And if a record is updated, a copy of the record with the old values is placed into the deleted table, and a copy of the record with the new values is placed into the inserted table. That allows us to use the appropriate joins and filtering to decide whether we're going to put a value into the added on and added by fields in the record in the table, or whether we're going to put a value in the modified on and modified by fields in that table. If it's an insert of a new record, there will be a value or a copy of those values in the inserted table. There will not be a copy in the deleted table because nothing was deleted. By filtering out records from the deleted table where employee ID is null and using a left join, we're able to limit our update action to the added on and added by fields. However, if there are records in both the inserted and deleted table, that means it was an update. When that happens, we need to change the values in the modified on and modified by fields. Filtering on records in the deleted table where the employee ID is not null limits the action to updates only. All of our triggers and all of the tables which have triggers have this identical structure. The only difference would be the table on which they act. One other thing I wanted to call out, you'll see that I've used the date time data type for these fields. In SQL Server, you can use the date time to data type, which has a much greater precision. Access doesn't handle those extended date types, the date time to types, very well. Therefore, I tried to be consistent in using date time so that it will remain compatible. Northwest Dev also includes a few system tables. These are important for future phases, so here's a quick overview. The catalog table of contents will be used when we generate a printable catalog with page numbers and an index and images for our products. Employee privileges. This will work with the security roles and support the multi-user scenarios. Learn, internal help, and links to documentation. Menu options. This is a new table I added to serve the same role that the USys ribbons table served in the Access database. The USys ribbons table contains the XML that is used to generate the ribbon or the custom ribbon. My menu options table contains the same icons and text used for the menu in the PowerApps version. Northwind features, that is a table that allows us to provide a more user-friendly, in-depth documentation of how Northwind works. We'll expose that later. In order to replace the SQL Server error messages with custom error messages and custom error numbers to provide a more user-friendly experience than the raw SQL errors, I added this table. It handles those errors in the same way that the strings table did in the Access side for other things. It's strictly limited to errors, though. System settings and user settings are where we store things like whether or not to show the initial welcome screen and the login screen for users. Let's talk about relationships. I'm only showing 5 of the core tables. If I start putting too many tables in, it becomes unwieldy. In the center of the screen, I put the products table because that's really at the center of everything that Northwind does. Products are related to both orders and purchase orders. They are line items on a purchase order detail. So each purchase order has one or more purchase order details, and that's the one-to-many relationship you see here. Each product can be included in one or more purchase orders. We have a many-to-many relationship between products and purchase orders handled through the purchase order details table. So each purchase order can appear in the purchase order details table multiple times with multiple products. The same is true when we sell products. One order can contain multiple products. Each product can be sold in multiple orders. Our many-to relationship between orders and products is handled through the order details table. Those of you who are familiar with access and relationships don't need any more discussion than that. If you don't understand what I'm talking about here, or if it's new to you or you're not terribly confident, I suggest that you invest some time learning about normalization and proper table design. There are other relationships between employees, companies, and so on, including the self-join that I previously showed you for an employee and their supervisor. In this view, I've added the rest of the core working tables in the Northwind Developers Database. I hesitate to call it a complete data model, even though for the purposes of Northwind development, it is complete. Let me explain. The data model you see supports the business model behind Northwest Developers Edition. If the Northwest Developers Edition had a more complex business model, then the data model would be that much more complex to support it. So when I use the term complete, I don't mean that everything that can possibly be included is included. I mean that all of the functions in the business model are supported here in the data model. One example of that might be order fulfillment. Our rule in Northwind Developers is that all of the items in an order must be allocated before we can ship that order. If we have 5 line items, 3 of which have fully allocated products, but one of the items on that order is in no stock or on order status, can't be shipped, then we say we will not allow that order to be finalized until that last item comes into an allocated status by bringing in new inventory on a purchase order. In some business models, they may have a different rule. They may allow partial fulfillment of orders. They will allow an order to be shipped with 4 out of 5 items, holding only the 5th item on a back order status to be delivered at a later date. If those rules in that business model called for more complex data, this data diagram would be correspondingly more complex. Now, you might expect that at this point we'd go right into PowerApps, open up the data pane, and connect to this SQL Server using these tables like a typical app. But in this project, we took a different approach. Rather than relying on PowerApps built-in data forms or bound data sources, I'm using a fully unbound model. That means no bound forms, no direct editing in galleries, and no use of the patch function. Instead, all interactions with the SQL Server database are handled through stored procedures, custom written for each operation. PowerApps gathers and passes in parameters and receives structured responses. This gives me more control, simplifies security, and keeps the PowerApps front end lightweight. In addition, it means that all of the business logic stored in those stored procedures can be applied to any interface to which it is connected, whether that's an Access interface, a PowerApps interface, or a web interface. I'll explain this architecture in full starting in the next video, and depending on how deep we need to go, that may span 2 or even 3 videos. To recap, we used SQL Server Migration Assistant to bring our access tables into SQL Server, handled a few special cases manually, and reviewed the core relationships and supporting tables. This database now reflects our working data model, which in turn reflects our working business model. It's ready for CRUD operations, workflow validation, and interface design. In the next video, we'll dive into the PowerApps front end, and I'll walk through how I wired up the app to call stored procedures instead of relying on standard PowerApps data sources. Thanks for watching. Be sure to subscribe so you don't miss what's next.